Good morning, everyone. So, actually, Alexandra earlier this morning already said what I was going to talk about. So it kind of spoiled my presentation. But anyway, this is the actually, but I'm not going to discuss about the RERI standard. That's what Alexander said. I'm just going to mention it, and then I will provide you with an overview of the peripheral that we developed that is compliant with the standard, the RISC-V standard for error logging and reporting. So it is a kind of service peripheral that can be applied in many domains, probably even in space. Let's see. So what is RAS, Boris? So actually, there was an interesting discussion yesterday highlighting that when people talk about electronic systems, they are always focused on performance, energy efficiency, and they take for granted that the system is going to be operating as expected, but unfortunately that's not always the case, especially in space applications. And that's the reason why you need to do something to provide not only reliability, which is the probability that the system works properly over time, but also availability. So the system that is able to provide the intended service when it is required, and serviceability. So the ability of the system to give you the information that you might need to serve the system itself in case of a failure. So that's what RAS is. So in space applications, actually, there are kind of standard approaches to provide fault tolerance, so reliability, actually. So you may rely on modular redundancy, so you triplicate control logics, data paths, or even the whole system. You, of course, have ECC error correcting codes for memories, and which is, again, a kind of standard. What you could do also to provide some kind of flexibility to the, let's say, solutions that, to provide, that are able to guarantee the correct operation, you can implement a hardware, software, error logging interface, login and reporting interface that can help you improve reliability by triggering the, let's say, the software system in case the correct functionality needs to be retrieved, or even, and by triggering the software only when it is actually needed. So, I mean, having a good effect on the availability, and also provide, as I mentioned, the by storing the important information about the error events, so it can help service the system when it has failed. So for the RISC-V kind of architecture, there's been recently developed a standard. So there was a task group, a RISC-V task group, that developed this standard RERI, that's how it is called. That means that stands for RAS, Error Record Register Interface. So that provides you with the, let's say, requirements when you want to develop a hardware software interface for error logging and reporting. Actually, it provides you with the error taxonomy, so a kind of classification of the error that you can expect. And also what is the infrastructure that you need to implement in terms of the register, these ad hoc memory mapped registers that needs to be implemented in order to store the relevant error information. And also it tells us how actually how you can configure the reporting features, and when actually an error needs to be reported to the system software in order for it to intervene and represent the correct operation, for instance. But it is not so restrictive as a standard, and actually that's what a standard should do, because it provides a pretty fairly large room for flexibility. So I would say that in this case, standardization also leaves some design room also for customization. So a designer can decide what kind of features they want to implement, actually. And of course, they don't say anything, the RERI standard doesn't say anything about how you should implement this kind of feature. So this is entirely up to the designers. So, and leaves some space to optimize the system according to actual requirements. So starting from the error taxonomy, so of course error can be either detected or undetected. If they are undetected, you cannot do much about that. And if they are detected, you can correct them, of course, and you can count them in order to, let's say, have a kind of picture about the statistics, about what's going on in your system. And if they are uncorrected instead, of course, they may need to be immediately dealt with by the system software in case the erroneous data are going to be immediately consumed by a system. And these are the critical errors. But in case, if this is not the case, if errors are not going to be immediately consumed, you can just label them as poisonous and keep this and store this message in your infrastructure, not stored in infrastructure. And whenever they're going to be consumed, this deferred error can be escalated to critical error and then dealt with by the system software. And of course, the severity of the error increases this way. We have this set of ad hoc register that needs to be implemented. You have some headers clarifying the properties of this set of register, and then a set of error record that you can, where you can implement the useful information for your errors. What is the what kind of errors, if it is a corrected, if it is just detected, where the source of error and these kind of things, and also the address of the erroneous location, the timestamp. Okay, but this again, most of these fields can be customized by the designers. You don't really need to implement all of them. We advise this login and reporting interface consisting in a pre-process stage and an error log and report stage. For the pre-process stage, so we are collecting the erroneous information from the hardware monitored unit and then combine them with the address coming from the address bus, and then provide it to the next stage, the error log and report stage, which is in charge of selecting the register where to log the information, and also can decide when to trigger the system software in order to represent the correct information. So there is a big, let's say, design space where you can play with according to the specs of your application. So you can decide how many actual instances of the peripheral you want to implement. For instance, if you want to implement different features for different monitor hardware units, then you need to have multiple instances also of your peripheral. And also you can decide what kind of information you want to implement. So this is one of the features that you can play with. And in terms of error record, really, that you need to implement, so you see there is a huge possibility for customization from the minimal log, and yet being compliant with the RERI standard. So the minimum login, just 18 1-bit register, and the full login, actually you need 325 kind of register in order to store the information. And this is again up to the designers to decide. So we have also implemented and assessed the let's say the hardware overhead of our peripheral in these changes by varying the number of hardware unit, and of course in this case the most important, the most impacted stage is the pre-process that is directly interfaced to the monitor hardware unit. So these green bars, Whereas if you, of course, change the number of error records that you want to implement, of course, this has a huge impact on the error log and report. Also, if we consider the AXI4 interface that you need to implement in order for the processor to access these memory mapped registers. So again, but still you can select the proper number of error records according to your applications and yet be compliant with the RISC-V standard. So, conclusion now. We have developed this hardware-software interface that we called Engage5, which is compliant with the RERI standard that actually the University of Pisa contributed to define. And as a future work, we would like to further optimize the logic of this interface, see whether we need to provide some fault tolerance to the interface itself, but being a service, let's say IP, might not be actually needed. We will see. And of course, we still need to, let's say, develop the software solution that needs to be on top of the interface in order then to apply some kind of rollback or checkpoint in order to re-establish the correct operation in case there is a failure of our system. Okay, thank you.